Hello everyone, welcome to Okul. Let's continue this journey of theories of machines. This is part 5 of the simple mechanisms and the last part of the simple mechanisms. Okay, in the previous part we have seen the basic concepts of the mechanisms, the degree of freedom concept, the Grubler criteria, the Grashoff's law for the relative motions of the 4-bar mechanism, and also we have seen the inversions of the simple 4-bar mechanism and also the single slider crank mechanism. Today's lecture we will be covering the basics and the inversions of the double slider crank mechanism. Okay, so before proceeding forward, let me remind you, if you haven't subscribed to our channel yet, please do it at the earliest and also press the bell icon so that you may get the notifications of our newly uploaded videos from time to time. So let us begin with this. It's a double slider crank chain. It says it's a double slider crank chain. What's a double slider crank chain? It consists of 4 links. So again, it's a 4-bar mechanism, but it consists of 2 turning pairs and 2 sliding pairs. Okay, there are 2 turning pairs. What are the 4 links? Here you can see this is the link 1 that has been shown. Okay, this is the link connecting the 2 sliders. Okay, this is your slider 2, slider. Okay, this is again your slider. So this is your link 3, and the slotted bar is your link 4. Okay, so there are 2 turning pairs. You can say the turning pair, one turning pair is this, that is between your link 1 and 2. Okay, then there is one turning pair here that is between link 1 and 3. And then there are sliding pairs, that this is one of your sliding pairs between link 4 and link 3, and one more sliding pair here between your link 2 and link 4. Okay, so it consists of 2 turning pairs and 2 sliding pairs. So let us see what are the inversions. So there are 3 things which can be fixed. One is, if your slotted bar is fixed, we get that inversion which is called as your elliptical tremors. Okay. Second inversion is, if any one of the sliders is fixed, the inversion that we obtain is known as your Scotch-Yoke mechanism. And the third one is, if the link connecting the sliders is fixed, we get an Oldham's coupling. Okay, so now let us understand them one by one. So starting with the electric tremor we say that the slotted bar is fixed. Okay, in the slotted bar is fixed, then how this mechanism functions, let us see with the help of this video. See this. See. The slotted bar is fixed and the link and the sliders are moving. Just simply see this point. Okay, just simply see this point, how this point is tracing the path like your ellipse. Okay, when the slider and the link is moving, you can see the path that has been traveled by this point. Okay, this is traveling at a point which travels the path or which makes the path as a ellipse. Okay, hence the name came as elliptic tremor. Okay, so please remember one thing. If this link, any point on this link other than the center, okay, please remember, any point on this link other than the center, the locus of that point will be an ellipse. Okay, hence this name elliptic tremor. Okay, but if we take or if we consider the locus of the center point between these 2 links, that is these 2 sliders, then we get a circle. That is a very special case of the locus of the midpoint of the link connecting the 2 sliders. If we take the locus of the midpoint, we get a circle. Otherwise, in every other case, we get your ellipse. Okay, hence this name is your elliptic tremor. And this is the inversion of the double slider crank chain when your slotted bar is fixed. Now let us see the another inversion that is known as your Scotch-Yoke mechanism. Okay, so Scotch-Yoke mechanism, first of all, let us understand it through the help of this video, and then we will see that what is the basics about it. See this. See, this is the inversion that is obtained when one of the sliders is fixed. Okay, the center through which it is rotating, you can take that as one slider. Okay, and the other slider is moving. Okay, so another slider is moving, so you can clearly see that how the motion has been translated. The rotation motion has been converted into the translational motion. This is the Scotch-Yoke mechanism, and this is used in the hacksaw cutting blade. In the workshops, you might have seen that there is a hacksaw cutting blade. Okay, so there this mechanism is used. Now let us come to this analysis. In this, I told one of the slider that this slider is fixed. Okay, this slider is fixed, and when this slider is moving, this slider is moving in a circle like this. So what is happening? You can yourself see that there is a rotational motion of this link. Basically, this link is rotating. You can say this link is rotating. So the link this is rotating. So this slotted bar is doing a translational motion. So this is another inversion of the double slider crank chain in which one of the sliders is fixed. Now let us move on to the third and the last inversion of this double slider crank chain. in which the link connecting the two sliders is fixed. Here you can see that this is the link connecting the two sliders and this is fixed. Okay, so let us understand it through the help of this video again. See this. The link connecting the two sliders is fixed. So this mechanism is basically used for the connection of two shafts which have lateral misalignment. Okay, this is the line of this shaft. Okay, and this is the line of this shaft. So basically you know that this is the line this is the line this. So they have lateral misalignment. This is the lateral misalignment, and this coupling is used for the transmission of power, or you can say the connection between the two shafts which have lateral misalignment. Okay, you can understand it. This is known as your Oldham's coupling. This is the inversion of the double slider crank chain when your link connecting the two sliders is fixed. Okay, now let us see one more mechanism that's known as the Watt's indicator mechanism. Watt's indicator mechanism, this was developed by Sir James Watt to identify or to determine the steam pressure that has been generated. Okay, so this mechanism is, in this mechanism there is no relative motion. Please remember, there is no relative motion between BC and CD link. Okay, you can see that there are two links like BC and CD, so there is no relative motion between BC and CD link. Hence this mechanism or this BCD behaves as one link. This is the first observation that we get from this. Okay, another thing is that point C and point Q moves in approximate straight line. Please remember, the point C and point Q moves in approximate straight line. Hence this mechanism is also known as approximate straight line mechanism. Approximate straight line mechanism. Okay, please remember this. Approximate straight line mechanism is your Watt's indicator mechanism. Okay, and the second thing is your AC and AQ. Okay, your BCD and AQ moves as lever. Okay, they both moves as a lever. So it's a, you can say it's a double lever. It's a double lever or double rocker mechanism. Please remember this. Okay, it's a double lever or a double rocker mechanism. Okay, so these are the observations about this, that is BC and CD behaves as one link because there is no relative motion between them, and the point C and Q moves in approximate straight line. So this is an approximate straight line motion mechanism, and this is also a double lever or a double rocker mechanism. Okay, so thank you for being a part of this lecture. This we have completed our simple mechanisms, and now we will be proceeding with the another topics of these subject, that is theories of machines. The next chapter will be, or the next video will be of velocity analysis, and then we will move on with another concepts. And in between you will also get some of the videos for the important previous year questions, where we will see that what kind of questions has been asked from this topic in the examinations of GATE and engineering services. Okay, so if you have any queries, any doubts, you can write to us in the comment section below. And also if you want to talk to us, if you want to have some connection with us, then you can connect with us through our Facebook page, Twitter page, Telegram channel, and also through our website and the email ID. All the links have been given in the description below. So please like these videos, share these videos so that others may also get benefit out of it. And also do subscribe to our channel, and please press the bell icon so that you may get the notifications of our newly uploaded videos. So thank you for being a part of this. Stay tuned for the upcoming video. Till then, thank you and have a nice day.